And unlike the previous example, the two cubic polynomials are not equal, so that means that our greatest common divisor is of the lower degrees, maybe 2, maybe 1, or maybe A and B doesn't have any common factors. Okay, so let's reduce again the degree of these two cubic polynomials. Let's call this one D and this one F. Okay, and we don't need these two because are of the degree of 4. Now we first get rid of the x cubed term by multiplying this by 5, this polynomial by 5, and this by 2. So the x cubed term here becomes 10, and here becomes 10 also, and by subtracting we could get rid of that, and later we could get rid of the constant terms by multiplying this by 4, so this becomes 40, and this by 5, this becomes 40, and this by 4 also 40, and add this together. Okay, so let's let's write it here. So first 5d, or this 5d, 10, 5 times this, minus 7d. Okay, am I right? 5, yes, minus 50. Sorry, and this by 2, 2f. 2f is 10 here, minus 14, minus 28, minus 4, 60. And add these two, subtract one from another. Let's subtract this from this. So this is 2f. So this is 2f minus 5d. That would be 66 minus 4, again 66. This minus this, minus 33, right? No? Yes. And this 0. And this is a quadratic, so this time we get rid of the constant terms. Okay, by multiplying this by 4, so 4d 4D, that would be minus 4D. 4 times this is minus 56, 4 and 8, and this by 5, 5F, and one thing here is that you may think that this method takes much time, but here I should explain every step, so if you use it by yourself, or if I use it by myself, that would take me much less time. Okay, and here the rational root theorem doesn't work for them. For instance, the divisors of -2 doesn't make, none of the divisors of -2 doesn't make it vanish, and also doesn't work here, the rational root theorem. And dividing this by this as before may be complicated and take much time. Okay, so this is a good way. Okay, let's continue. And 5F, 4D here, here minus 10, here minus 70, and here 20. No, 20, 25. Okay, and let's adding these two, the constant terms cancel each other out, so here would be 0, and the resulting polynomial would not contain the constant term, so could be written as x times another polynomial. Okay, and since it is a cubic polynomial, so inside the parentheses would be of the degree of 2 or quadratic. So instead of writing 0 here and then shift everything here, everything to the right, one step to the right, let's write everything starting from here, and this plus this minus 66, and this is it. And inside the parentheses contain all the common factors of a and b. So this is minus 66, this is also minus 66, no, this is minus 66, I wrote it down here, and minus 7, this is 7, minus 70, okay, minus 70 plus 4, again minus 66, and 25 plus this, 33, and this is 4D plus 5F, and this was 2F minus 5D. Okay, and again D and F the greatest common divisor of f and d equals to the greatest common divisor of a and b. So we got two linear combination of f and d which are not equal, but one is the negative of another. So there is the greatest common divisor is 33x squared minus x minus this, let's write it minus 2x minus 2. Okay, so the greatest common divisor is this, since the constant factors doesn't count in the greatest common divisors. Okay,